In September 1977, NASA's Voyager-1 spacecraft began its long journey into the unknown when it was launched from the Kennedy Space Center 16 days later than its twin Voyager-2. The probe's main objective was to conduct close-up studies of the outer planets, including their large moons and mysterious ring systems. Voyager-1 was launched on a faster, more direct path that would send the spacecraft hurtling towards Jupiter and Saturn, while Voyager-2 would take a slightly different path that would also take it past the two gas giants, but then onto Uranus and Neptune, taking advantage of a rare planetary arrangement that only occurs once every 175 years. Within just a couple of weeks of its journey, Voyager-1 sent back its first images, one of which reveals a crescent-shaped Earth and Moon hanging in the darkness of space. This incredible image was the first of its kind ever taken by a spacecraft, and was captured when Voyager-1 was 7.25 million miles away from Earth on the 18th of September 1977. You can see the moon at the top of the image, while a blurry Eastern Asia and Western Pacific Ocean is visible on our blue planet. Because of the direct path that Voyager-1 was set on, it only took the spacecraft approximately 1.5 years to get to the first and largest gas planet in our solar system. In January 1979, Voyager-1 began taking photographs of Jupiter during its approach, and captured almost 1,900 images during the flyby. This time-lapse records Jupiter over a period of 60 days, and shows the gas planet's swirling clouds rotating within bright bands, exceeding any image ever taken of the planet from Earth. Incredible close-up images of Jupiter's famous storm, the Great Red Spot, was also captured like never before. By using colour filters, the image reveals the turbulent nature of the giant storm, plus large white spots that surround it, as well as giving us a closer look at Jupiter's marble-like atmosphere. Voyager-1 also observed for the first time Jupiter's thin ring system, which can be seen as a faint band across the centre of the picture. The edge of the ring is approximately 35,400 miles away from the planet's visible cloud deck, and the background stars in the image appear as broken hairpins due to the spacecraft's motion during the 11-minute exposure. But it wasn't just Jupiter that Voyager-1 studied. Many of the gas planet's mysterious moons were also photographed, such as the volcanic moon Io. In this image, you can see hazy details of Io's hellish surface, revealing ancient volcanic scars that are spread across the moon's landscape. Io was the first world beyond Earth where active volcanism had been observed. The huge plume can be seen silhouetted against the darkness of space on the outer edge of the moon. By using different camera filters, the close-up image also shows the moon's rich colours, which are believed to be as a result of allotropes and sulfur compounds, while the dark spots may be from lava flows or volcanic craters. Other satellites such as Jupiter's largest moon Ganymede also exposed its strange surface features for the first time, revealing huge ridges, grooves, and impact craters that are spread across its icy thick crust. After months of studying Jupiter and its moons, Voyager-1 eventually completed its flyby in early April 1979 and continued on to the second largest gas planet in our solar system. Nearly 20 months later, on the 9th of November 1980, Voyager-1 finally reached the ringed world Saturn. This blurred image shows Saturn's dark and light bands of rotating clouds, its huge magnificent ringlets, but also two of the gas giant's mysterious moons. During the flyby, Voyager-1 also encountered Saturn's largest moon, Titan. The enhanced photograph reveals Titan's hazy, nitrogen-rich atmosphere, which led scientists to theorize that seas of liquid methane and ethane might exist on the moon's surface, which was later confirmed by the Cassini mission back in 2004. 8 hours after its closest approach, Voyager-1 snapped this picture of the planet's ring system, revealing hundreds of magnificent bright and dark ringlets that consist of trillions of small icy particles, plus larger scattered boulders. Voyager-1 collected colossal amounts of data and discovered 3 previously unknown moons during its flyby, but from this point onwards, its primary mission was complete, and the spacecraft would never come close to another astronomical object again. But at a distance of about 4 billion miles away, Voyager-1 was commanded by NASA at the request of the astronomer Carl Sagan to point its camera back towards the Sun one last time. In February 1990, the spacecraft captured a series of images that became known as the Solar System Family Portrait. The mosaic consists of 60 frames that, once magnified, revealed Venus, Earth, Jupiter, Saturn, Uranus, and Neptune. It is the first ever portrait of our solar system as seen from the outside. The famous photograph of Earth became known as the pale blue dot, and captures our planet as a tiny blue speck in a magnificent beam of scattered light. After all of the images were transmitted back to Earth, engineers turned off the spacecraft's cameras so that it could power other instruments as it continued on its journey into the unknown. Then, on the 16th of December 2004, 24 long years after its Saturn encounter, Voyager-1 crossed the termination shock, a region where solar wind abruptly slows down and heats up as it encounters interstellar wind. Here the spacecraft would have to travel through a turbulent area known as the heliosheath, which is the outer shell of a bubble of charged particles around the solar system. Voyager-1 finally became the first human-made object to cross the threshold of interstellar space on the 25th of August 2012. The incredible spacecraft that was only built to last 5 years is still collecting data 13.5 billion miles away from the Sun, detecting the full intensity of cosmic rays beyond our solar system. According to NASA, the spacecraft will have enough energy to power its instruments until 2021. Then, it will pass through interstellar space until it eventually comes within 1.7 light years of a star in the Ursa Minor constellation, around 40,000